Hi everyone, my name is Rajan, and today I'm going to be discussing the solution to the problem fence, which is given by 363b. So this is a 1100 rated problem on Codeforces. So let's quickly go through the question, see what it says, see what it wants us to do. So there's a fence that's given to us. So this fence consists of n planks, which have the same width, but they have varying heights. So the height of each plank is given by h of I for the ith plank, and they go from left to right. So if we go ahead and skip most of the story part, what we essentially need to do is find k such consecutive planks such that the sum of their heights is as small as possible, which is what's given here. So if we take an example, so let's say we have n equal to 7, which is the number of planks. The height is given by the array h, where the elements are 1, 2, 6, 1, 1, and 7, 1. And this is the visual representation of those planks. So before we go ahead and discuss the approach or essentially what we need to do, let's quickly look at the constraints of the problem. So we have time limit per test given as 1 second. So we need something of, let's say, like an O of n solution to get this working, because the input criteria for n varies up to 10 power 5 and k is up to n. So it lies between 1 and n. So let's quickly go ahead and look at this example and figure out the logic behind this question. So go ahead and look at the example they've given us in the problem, which is the same as the visual example they gave us previously. So if we analyze this, what we are given here is this is the value of n, which is the number of planks, and this is the value of k, which is the k consecutive planks that we need to find for the minimal sum. So essentially what we need to do is we need to start from the starting of the array, and we need to form like a group of three and find the sum of those three elements, because the value of k here is 3. So if I go ahead and do that, that means we're finding the sum of 1, 2, and 6 first. Then we're going ahead and finding the sum of 2, 6, and 1, followed by 6, 1, 1, then 1, 1, 7, then 1, 7, 1. We're doing this until we reach the end of the array, of course. So if we go ahead and write the sums that we've obtained, so 1 plus 2 plus 6 is 9. Then we have 2 plus 6 plus 1, which is again 9. Then we have 6 and 1 and 1, which is 8. And then we have 117, which is again 9. And then 171, which is again 9. So as we can see, the minimum sum that we've obtained here is 8. And what we essentially need to do as or return as the answer is the index that we find this minimal sum, or the first integer of that minimal sum. So as you can see, given in the answer to the first input, we have 3. That's because we have 611 as the minimal sum, and 6 occurs in the third index, assuming that we're going at like the 1 based index. Otherwise, our answer would be 2. So since we're not, the answer is 3, and we get that as our answer. So how exactly are we doing this in the first place? So we're essentially, as I said previously, we're going ahead and forming a small group of k elements starting from the first one, and we're finding the sum of these k elements, and we're looking at the minimum sum for these k elements. Wherever we find the sum, we go ahead and return the first index where we found it. So how do we go ahead and implement this logic into C++, which is the language we're going to solve this problem in, right? Um, so if you're familiar with uh, problem solving in general and the way I drew these lines around these three, you would know, or you would get a sense that this problem involves sliding window or a two-pointer approach. So for this particular problem, I'm going to go ahead with the two-pointer approach, see how that works. And even if you don't know what the two-pointer approach is, I'm going to try my best to explain sort of what two-pointer approach is while trying to explain the solution of the problem. Uh, so let's quickly go ahead and see what the two-pointer approach is and what that would look like. So let's say I have two indices that I want to keep track of, one being L, which stands for left, and one being right. So since I'm starting from the beginning of the array, I would say that L is equal to 0 and R here should be the kth place, right? But since k here is given as essentially the numeric value, and since we need to convert it in sense of the array, what we're going to do is take R, or the rightmost index, as k minus 1. So what this essentially means is, if we're looking for windows of three elements, that means we have 0, 1, and 2 as the first window that we're going to search, which basically works because array indexing starts from 0, as you all know. So what we're essentially going to do is we're going to find the sum of these elements between L and 0. So one way we could do this is use a for loop. So we could say, let's say, if I had to write the pseudocode, if I have an integer I which starts from L, which goes up to R and increments by 1, I would want to find the sum and add it to the existing value of sum, then go ahead and add, essentially a of I, assuming that this array is given by A. But the problem with this is the values or the input constraints that we have, which is, essentially k that could go up to the value of n. Right. All right. So one thing I forgot to explain here is when are we going to do this? Essentially finding these sums, right? We're going to do it until we find the end of the array, which means if R is our rightmost index, R should be less than k. So we're going to essentially do this till the value of R is less than k. So we could essentially say that we're going to do this while R is less than k. So we have that sorted out. So we have one loop already in place. If we go ahead and use another loop for finding this sum, that would go ahead and have get more haphazard, because the input constraints that we've given are, n value goes up to 10 power 5. So 10 power 5 times 10 power 5, essentially, because we have an O of n square solution, two loops, one within each other, and the time limit per test given as 1 second, that would be really bad, and we would hit a TLE, or a time limit error, instantly on Codeforces. So rather, what we would do instead is go ahead and use this approach of two pointers along with the concept of prefix sum. So what a prefix sum essentially is, again, if you already know, you don't need an explanation of what prefix sum is, but for those who don't, a prefix sum is another array which basically contains the sum of all of these integers. So instead of having to go through a loop to find the sum of integers from, let's say, L to R, what I would essentially do is, let's say we have our array here, which is 1261171. So my prefix sum would look something like, so 1 and then 3 and then 3 plus 6, which is 9, 10, 11, 18, 19. So this is the second array, which I could say prefix is equal to prefix sum. So if I have to find the sum between any values L and R, which in case I have gone ahead and defined as L as the starting position and R is k minus 1. So let's say I want to find the sum of the first three elements, which is 1, 2, and 6. So what I would essentially do is go ahead and find the sum of 9 minus 0. Why 0 in this case? Because L is equal to 0. If L is equal to 0, the sum would essentially be whatever element that's located at the rightmost index, which is given by R. Let's say L is not equal to 0 and L is some value. So then we would have the sum given by prefix of uh, prefix of R minus prefix of L minus 1. So if I go ahead and look at this example here, 261. So since the leftmost index is not 0, since it's not the starting element, so I would essentially get R as 10. So 10 minus 1, which is what I'm doing, 9. 9 would be the sum I'm getting, which is the correct sum that we get, right? Uh, so by going ahead and implementing this prefix sum, we are getting the values of the sum in a time complexity of O of 1, because all we're doing is just subtracting these values. We're not going ahead and implementing a loop through the elements of this array, which is called prefix. All right, so now that we've sorted out prefix sum, so once we're given this array, we'd go ahead and make the prefix sum of that particular array, which is given by this for our example. Then what we're essentially doing is finding the minimum out of these sums that we found. So while we have this loop, while r is less than k, what we're doing is we're going ahead and finding the minimum sum. So if L is equal to 0, R is equal to k minus 1. So I would say that some value sum is given by, let's say I would write an if condition here for L equal to 0 or L equal to L is not equal to 0. So I'm not writing the full code here. Obviously, I'll be showing you the code to get an idea. But let's say I have to write the pseudocode. So what that would look like is, I would say if L is equal to 0, then the value of sum is A of R. Otherwise, the value of sum is A of R minus A of L minus 1. Then let's say I'm keeping the track of some variable called minimum sum. Why am I doing this? Because I need to find the minimum most sum out of all the sums that I've obtained. So I have a variable called sum, and I also have a variable called minimum sum. So then what I would check is if sum is smaller than minimum sum. So over here, I could technically use the built-in function, which is minimum of uh, minimum of two values. So I could just have minimum of sum and min sum to get my answer. But I'm not doing that. Why? I just tell you now. So I'm going. So if sum is less than min sum, we'll go ahead and update min sum as sum, and we'll say that let's say we have another integer or another variable called minimum index, which is where we find this minimum sum. Now, where do we go ahead and find this minimum index? This minimum index is found at the value of L, if you remember. Because let's say we start from here. So I'll trace an example to get a better understanding. But let's say we start from 1 to 6, 1171. So L starts from here, and R, which is k minus 1, ends up being here. So our value of minimum sum, or the first integer of this k elements, is would be the left one, right? So I would go ahead and say minimum index would be the left one. which is, essentially L. Uh, Instead of saying L, I would say L minus 1 because we're using a zero-based index, which is what we need to find. Again, there could be an if case here where we would say if L is equal to 0, just keep L value as it is and don't do L minus 1. But since we don't really need to do that, because guess what? The answer they want us to give starts from a one-based index. So all we need to do is actually do L plus 1 instead of L minus 1. We don't need to worry about L being 0 and accidentally printing minus 1. All right. So if sum is smaller than minimum sum, this is what we're doing. And when do we do this? So this whole thing is in a while loop. And so if this thing does not occur, what do we need to do? We need to change the value of L and R to go to this next three integers together. So how do we do that? We increment L and we also increment R, which is essentially L plus plus and R plus plus. So let's quickly go ahead and track this pseudocode that we have. So instead of using this actual array, I would go ahead and use this prefix array because that's what we're doing here. So A here is actually not the actual array. This is my bad, but the prefix array. Let's say it's represented by P. So I have P as the elements 1, 3, 9, 10, 11, 18, and 19. So while r is less than k, so we've gone ahead and established L is equal to 0, r is k minus 1, and then we have these integers, or we have these variables, which is minimum sum and minimum index. I'm not going to write them here. This is what we're going to essentially initialize or create. So we have this array. So if L is equal to 0, the sum is given by P of R. So since at the first L is equal to 0, P of R or P of k minus 1 is 9, which is the first sum of elements which we found over here. So the first sum we have is 9. Then we check if sum is smaller than minimum sum. So we're going to go ahead and establish minimum sum to be some arbitrarily high value such that even for the first case, the value of sum is smaller than minimum sum. So we're going to go through this if statement. So we're going to say that minimum sum is equal to 9 and minimum index is given by L plus 1. So we have 1. Then we're going to go and do L plus plus and R plus plus. So if we had this, then what we're going to do for the next iteration of the while loop, we're going to have this. So let's check this sum. So since L here is not equal to 0, what I'm going to do is sum is P of R minus P of L minus 1, which is essentially 10 minus 1, which is 9 again, which is what we found here. So if sum is less than minimum sum, that's not true, right? 9 is not less than 9. So this if statement doesn't execute at all. And we increment our while loop. We increment our pointers, which is, the left index and the right index, which basically looks like us going ahead and doing this. Now let's look at what we've got. So again, since L is not equal to 0, we skip this entirely. We say sum is equal to P of R minus P of L minus 1, which is 11 minus 3. Now what's 11 minus 3? That's right, 11 minus 3 is 8. That took me a while there, my bad. So 8. So we found that sum is somehow less than minimum sum, which because minimum sum's value is 9. So since that is true, we go ahead and see that minimum sum is equal to sum. So instead of 9, we go ahead and scratch that and we say the value is 8 and we say minimum index is L plus 1. So L over here is 1, 2, 3. My bad. So 0, 1, 2. So 2 plus 1 gives us 3, which is the value of minimum index currently. So we go ahead and do L plus plus, R plus plus. We check all these again. After the end of the loop, we still have the value of minimum sum to be 8 and minimum index to be 3. So we go ahead and print the value of this minimum index, which is our answer. So why did we not use minimum? Because minimum for these two values, because that would mean we can't essentially update this min index in this if statement. It's a much arbitrarily simple approach if we use uh, essentially an if statement consisting of two statements underneath these. So this is the approach. Let's go ahead and look at the code of the solution. So, what does the code look like? So, we have two integers, n and k, which is what's given here, n and k, and then we take the input. Then we also form this prefix sum. So, the first element of this prefix sum is always equal to the first element of the array. And we have this loop which starts from the first index, not the 0th index. So, we say that the first index of prefix sum is equal to prefix sum of the 0th index plus a of I, which is a of the first index. So this essentially gives us this prefix sum that we previously established during the explanation. And then we go ahead and say that the left and the right is given by L is equal to 0 and R equal to K minus 1. Then we say minimum sum, which is an arbitrarily high value because we need to find the minimum sum even at the first iteration, int max. So what is this int max? If you're wondering and if you don't know, since we have the variable type as int, let's say for a 64-bit machine, that would mean for an integer, 8 bytes are allocated, right? So int max, what it essentially does, for all of those bits allocated to that particular variable minimum sum, it goes and turns on those bits to 1. So that would essentially give us the highest maximum number possible for an integer, which is around 2 power 8 because we have 8 bits available. So that's what int max is, and we can go ahead and just say that is equal to int max, which gives us this arbitrarily high number. The opposite of that being, you guessed it, int min, which is essentially the same of that, but the sign bit of this integer is indicates that this is a negative number. So you have an arbitrarily small number. Then you have minimum index, and then you also have sum. So we have the loop while r is less than n, and we have the case if l is equal to 0, which is essentially the first iteration of the loop. We have sum is equal to prefix sum of r, else we have prefix sum of r minus l minus 1, as I previously discussed. So then we have if minimum sum is greater than sum, which is the same as if sum is less than minimum sum. We have minimum sum is equal to sum, minimum index is equal to L plus 1, because again, we are considering an indexing which starts from 1 rather than the conventional index of an array which starts from 0. Then we go ahead and say L plus plus, R plus plus, because we're incrementing the value of the indices, both of them by 1. Then we go ahead and print this minimum index. So I already ran this example. We're getting the value of 3. So in front of you, if I had to run it, so this gives us the same answer. So the time complexity of the solution gives us O of n, because all we have is one loop that's running, and all of these operations that prefix sum is also again one loop. There's no multiple loops or loop inside loop, which easily fits the time given to us, time limit per test. So yeah, that's the solution. Hope you enjoy the solution. Do let me know if you have another approach or a better approach to this, or if you have any questions regarding the solution. So that's the end of the video. Thank you. Yeah, tata, bye bye.